Again, my name is Greg McFall. I lead the West Coast for Life Sciences. You know, my honor, my privilege to be able to introduce Clare Augustine. Dr. Augustine has been with Amgen for a few years. She's doing a great semantics use case. I think you'll really enjoy this. How I view it, though, coming from the life sciences space, it's delivering product, manufactured product, faster, safer to the market. Secondly, when you think of Clare as a taxonomy, she's also a co-founder of a nonprofit that feeds almost 500 kids a day with a happy bar, a nutritional enriched bar. So not only is she a technologist, but she's also a part of nonprofit. With that, Clare Augustine.
Thank you, Greg. All right, I'm Clare Augustine. I'm the taxonomy management lead at Amgen. I've had many titles. This one was picked because the immigration officer understood what that meant. So I'm stuck with that. So I've had many titles like ontology lead. It's all about semantics, right? Ontology lead, taxonomy management lead, vocabulary lead, information intelligence lead, and this was the one we decided we'll stick with. And when I go to an immigration office for my visa, I try to convince them that I really have a job like this, and I try to explain what it is. So while I go through this presentation, it's about communication. A lot of what I do in my organization is about evangelizing what semantic technology is, what is reference data, what is a taxonomy and such. So today I'll talk about how we use semantic technologies to do data harmonization and data joining. Okay, and I have a PhD in biology, so I don't use a lot of IT terminologies. I use simple words like join. So it makes sense to my audience, who are not just IT people in the organization, leaders from all different backgrounds, and I have to make a convincing point about this technology. All right, so let's talk a bit about Amgen, and our mission is obviously to deliver drugs to patients, and that's the mission statement for Amgen, and it also is for my Happy Bar Nutrition, where I'm trying to give a happy bar to several kids who are ostracized in far-off places because they have HIV and leprosy, two diseases that cause ostracism. And so this mission is, for me, it's very important and personal. And this use case that we're talking about today is also about logistics and getting the product to the patient right time, right place, with the best quality. Okay, and everything that we do, whether I'm in IT or research or product dev, it all revolves around these therapeutic areas. A little spiel about reference data. Okay, another word, reference data. What does it mean? Reference data is data that you refer to, right? That's why it's reference. So if you want to refer to something, it has to be a consistent language, consistent word. The meaning of that word has to be consistent and shouldn't change rapidly. So in most industries, there usually is a program called reference data, and no one understands what it is, and it's hard to get funding for that thing. And the only way I show the benefit of reference data is by doing innovative use cases with MarkLogic. Okay, so just going through this, you see the first bullet, it talks about reference data in separate systems. Okay, take an example of geographies, for example. You have hundreds of databases. Every database will have a table called geography, and you have a copy of the geography. The idea is, why do you want to do that? Just build a module and store it as reference data, and everybody consume from that one place so that maintenance is easy. The second point is different systems use different representations of reference data. This is easily explained by a problem that most companies face. Okay? So I'm going to use the example of pharma, where a product name can go through several morphologies as it moves through the pipeline. Okay? So imagine at the beginning of the pipeline, you might have a molecule name. As it moves through the pipeline, you might get a generic name. As it moves to commercialization, it gets a trade name. And then if you're using a device, it has a device name. So you have a pipeline, and you have this terminology around a single concept, which is product, and it changes over time. So what happens? Think of a researcher in research. He's discovered this molecule. What do you think all his file names are going to be called? Any Word document, any Excel sheet, anything will always be that molecule name, right? But then after he hands it off, the next team gets it and it's called a generic name. What do you think it's being called in that part of the pipeline, the generic name? And so on, it cascades, right? So that's different representations of reference data. And what we have to do is make the machine understand that that means the same thing, but it's called different. So the other thing that is important about reference data is the maintenance part of it, which is why a reference data platform always fails, because it's huge investment for one team to manage. It has to be distributed across the organization. I'm going to talk a little more about the pipeline. Everybody knows, every industry will have where you discover a product and where you launch it. So it goes through this pipeline. Now, since I talked about the product concept, right, and how the name changes, every piece of this is a silo of data, if you think about it. The terminology differences itself are causing silos within your organization. And I see a huge opportunity for us to join the data across the pipeline to enable a product to go faster to the market. Okay? So what are Amgen's challenges? And if I took off Amgen, see if this makes sense to you. Every one of us have this problem, right? Finding data. We search and search, we don't find it. We wrangle the data, we struggle, bring together data, joining the data. These are our three problems, and my job was to make it a non-frustrating experience, like in Netflix, for example. Netflix had a similar problem of getting new subscriptions, and so the CTO of the company, he decided he's going to tag, extreme tag every movie, right? And that's why we have a better experience. And similarly, we want to have a better experience at Amgen. Sorry, it's not. Okay. This is a pictorial of the problem, that's all. So many sources, so little time. Different words describing the same thing, right? This is an example. Same words describe different things. So you have site facilities, sites on a chromosome, sites on websites. Domain knowledge and context are not included. So if I'm searching for something about the aorta, the machine should know that it's about the heart. I shouldn't go and say aorta and heart, right? So I want to embed all of that. So at Amgen, we've got this modular approach. It ties back to what Gary Bloom and Ken were talking about in the morning. What are those concepts that are important for your organization? And build your reference data based on that. And when I joined Amgen, this is what we did. We just decided, let's think about what are the concepts that are important, and let's build our taxonomies on that. And it looks like this, okay? You've got all the things that are important for Amgen and all the connections between them. A product doesn't go on its own. You have to link it to location. You have to link it to a study or a person. You have to link it to so many things if you want a full view of that drug. So we came up with this approach, and we call it modular and linked, because I can literally mix and match any reference data and join data now, okay? I can take drug and location and device, and I can link them together. So I have a model now where reference data is all neat and arranged in different domains of data. And in order to link data, this is a very important piece, okay? And here are all the benefits that I place. You know, when Gary spoke about concepts, right, he talked about concepts and linking all these concepts together, and how it becomes easy for the machine to understand something like this. Because you've structured and you've told the machine, these are the things that are important. When I put data into some system, I want it to recognize any of these concepts. So Amgen, when I came in, I was looking for all these use cases to do based on this theory that I had that modular and linked reference data strategy would help us join many things. And so I listed all those questions that people could be answering in different parts of the organization. And Amgen has derived a lot of value operationally and analytically by using this approach. Okay? And operationally, you know, data and processes are always impacted by operations and analytics. And we've derived operational benefits in terms of cost reduction, efficiencies. In analytics, we've come up with better reporting mechanisms. It helps in risk management and reporting to different levels of the organization. So this logistics use case is the one I'm going to talk about next, which is, this was a use case where people were literally doing everything manually, okay? Every part of it was manual, and over 5,000 hours was being spent just to derive one metric. And every metric had to be generated every 3 months. And it took them 3 months to generate a metric. So the leadership always got wrong data. It was always mismatched. Okay? So what was the problem? Okay, let's talk about the problem. All of you have used Amazon, and all of you have received a package and you have been happy. Right? It's landed at your home, right destination, right time, right, one day, and the quality is good sometimes. So you know what's important when you get a package. Okay? So the most important things when you want to move a product or any product, a drug or any product, what are they? It's got to be your address, right? And then you've got to have the right transport service provider, a carrier to take it. Then you have to have a container or a package. Then you have to have the right sensors inside that package because you're pushing a drug on it, right? So, and then you need to know what the temperature is and how much it costs. That's the key information you require. So those are my concepts, right there. Those are important for me to do this logistics. But guess what, right? All of that was stuck in a Word document. So for every route that Amgen moves drug, we have more than 4,000. Every route has, so we have 4,000, but you can't find the route because there's no way to search into that Word document. You have a bunch of PDFs lying in a content management store with this crucial information in there, okay? And this didn't happen because someone was lax, right? Over time, Amgen created so many drugs, business was growing, you did what you could with the system you had, and we had a content management store, and all of that crucial information lay there. So that was our problem. How do I first remove that information out of the Word document? How can semantics help? And then secondly, how do I join it with any data from SAP, like orders, or any data from the sensor, temperature sensor? How do I do that if I didn't extract that? So we had two challenges. One is extract the key elements out. Second, join it with systems. I'll tell you why that was a problem. Okay? But without this, they could not ask a simple question. Give me a route between Thousand Oaks, California, and Netherlands. They couldn't say that. Give me a route that used a shipper with temperature 8 to 10 degrees. Give me a carrier that carries drug Neulasta. They couldn't ask very simple questions. Okay. So these were the data challenges that we identified. Okay. Valuable data stored in documents. There are challenges in connecting the data. Why? Because you did it in a Word document. You never thought of a primary key that we are also used to in a structured data. Never thought of that. So how would you join it with SAP? So we had a lot of those problems. We had lack of or limited master data management. Master data, again, a definition. When you go to a doctor's shop, when they're asking you your name, your social security, and your date of birth, that's master data. It uniquely identifies. Even that was not, it was limited. So addresses were in a bad shape and things like that. There was no platform to connect all of this. That has been my beef all through my career. Okay, 21 years I've been just looking for one place where I wanted to link and join and see all those bubbles connect up. I didn't have that ready. And so there was no platform to connect all of this. In terms of joining using semantics, that's what I mean. So here's a pictorial of that. And this, I keep saying, it's so difficult to explain to an organization that I want funding to do this if you don't have a picture and you can explain what a join means. Or what am I talking about extracting facts and all that. So here's an example, okay? This is a kind of a document. And this translates to so many more use cases in the organization. Luckily, this use case has kind of a hyper-structured document. And we use Semaphore there. They have a capability called fact extraction. And it has a unique way of understanding the anchors and pulling data out of it. Okay, so I worked with Semaphore, and we figured out a way how to do this. And it read through many documents and pulled out facts. Okay, so that was fact extraction. That was relatively the simple part of this project. We took out, it was innovative. We removed all of that stuff. But then data joining was a real problem, right? What were our challenges? There was no connecting key. How would you connect if you didn't have a primary key? And that's what we are so used to, right? We want a primary key to join two tables. That's what you want. So if I didn't make the connection to SAP, I could not do any analytics with the lane data and the order data. I couldn't give you any dollar amount kind of reporting to my lead. If I didn't make the connection to temperature, I could never say which lane had a temperature excursion, right? Did it deviate from what it should be? Did the product stay in Abu Dhabi in the harbor for too long under a bad temperature? What happened, you know? So I had to somehow join this. We used MarkLogic to do the data joining piece of it, okay? And so this is just a picture of the extraction. Once that data was extracted from those documents, you can see now the key concepts were taken out, right? I've now extracted the key concept. What are they? The addresses, the shipper, the carrier. And actually, if you click on the shipper, then the temperature required is also there in the metadata. So I stored all of this in, this is Semaphore, by the way. Okay, so fact extraction, and we created this reference data. So each lane was a fingerprint. This is a fingerprint of each lane, literally, okay? And for more than 4,000, now you have this unique fingerprint, and you know what that lane is. Now, just to deconstruct it further and make it look more familiar, like the way we're used to, right? So this portion here, this portion here is all that lane data that was extracted. The portion on top is SAP, which is order, and CCM is temperature excursion, okay? So this obviously is easy, right? But how, after you join this whole thing, how do you join it with this lane information, which is also different? Can you see this? If you match the colors, you'll realize everything is semantically wrong, right? It's not normalized, not harmonized. So So we built a complex key, if you will, a really ancient key. By the way, that's a picture of a really ancient key. It's not the modern key, but it's a really ancient key. Means it did some real complex stuff, obviously. So this is that. You have to now join by nearly 6 points, okay? No primary key, but you have to join by so many different points, and you have to do it by semantics. You have to join by semantics. That's why I said I didn't have a place to do such crazy stuff, and I found MarkLogic. Anyway, this is an example of, again, this is just UPS, okay? We have so many renditions of UPS. And it's so difficult between SAP and Lane. You have so many variations of a carrier. It's the same carrier, by the way. So there's no way they would join if I tried to join it. So we had to build a lot of reference data to do it. So it's quite obvious why I had a slide on reference data. So it's so boring there, but it's so exciting here. The glamorous version of reference data and all this graph and stuff is the magic, right? This is what sold reference data, by the way, the graph. Anyway, so this is going even deeper into that. And I don't have to explain smart mastering because Gary Bloom did a great job, right? All of you get it. I'm not going to say it because I'm not IT, I'm a biologist and all. So yeah, so we did all this kind of matching. But we also used another kind of reference data there, geospatial reference data. So the easiest way for us to do quite a few of the matches was geospatial join, right? We had addresses in Lane, we had addresses in SAP, so we did that. So once we did that, we nailed the route, right? But you still have to get the carrier and the shipper and the temperature join in order to make the perfect join between a route and an order. Because you can't go wrong with that, right? Because you're going to report this to the leaders. So we did all different kinds of joins, and we had a scoring system. Now, the scoring system is so useful, okay? Up till now, a lot of beautiful Tableau reports were being made, okay? Tableau can really give you some pretty pictures, right? So everybody was looking at the reports and saying, wow, this is great, it looks so good. This was the first time you could actually see these scores and see those Tableau reports were really not true, okay? The picture was pretty, but the data underlying was not. And this was the first time people had visibility to the data and the gaps in data, addresses missing, packages going to the wrong destinations, temperature excursions, no qualified places to store the product. So many things came out because data became visible. So we did all these mappings. First geospatial, we nailed the route. Then we did carrier and shipper. Then we nailed the route fully. Oh, sorry. Oh, what did I do? Sorry. Okay, so this is. I like this slide a lot, okay? This is actually a MarkLogic slide, but it explains what happened to us also. So during POC, the POC, by the way, was 8 weeks, and it took $60,000 to do the POC. And we borrowed money from 2 teams to do it because it requires so much convincing to do something very innovative. And so you can see here there were 3 data sources there, just 3 data sources, and we did the whole use case. But this changes often, okay? You want to ask lots of questions. You don't want to get into that route of, oh, I have one more extra question, so it's going to take another 18 months to bring that data in and ask that question, join it and ask that question. You want it to be flexible. The left-hand side is your Tableau reporting and all of that. Even that changes with the reporting needs, but the part in the middle has to be really flexible for new data to be added and in an agile fashion. So this is how we did our project, okay? We had the data sources, we had semantic data, we had geospatial data. What does this say? This just says that we had structured data, we had unstructured data, we had reference data or semantic data, we had geospatial data. We had different shapes of data, if you will, okay, or models of data. And all of that went into MarkLogic, and a lot of harmonization happened, and a lot of smart mastering happened, score-based indexing happened. Then we were able to see the data. Okay. This is such a technical slide, but I'll just go through it because we want to show what was our problem and how did MarkLogic solve it, right? What specific part of MarkLogic solved that problem? The first one is multiple data silos, formats, ownership. So it's as is MLCP. We used MLCP, we didn't use NiFi. So those are the different data types. The challenge of data synchronization. We did a lot of normalizing using both semaphore reference data and MarkLogic triple capability to join the different fields of the different schemas. Master data challenges. We used geoservices to normalize all our addresses. Fact extraction, we use semaphore. And matching, joining, whatever word you use, we use score-based indexing. Okay? So this was my vision, and even before we started the project, I actually drew this out, and I said, this is what I want to see. And when we went to the leadership, this is what I showed them. I said, at the end of this, you'll see this. And if I had not done that, and if I had shown a join diagram, right, if I had the dull join diagram, no one would have given me any money to do this. So the secret is that the visual, the front end is so important for you to sell a MarkLogic use case. I'm sorry, I rolled my eyes. Okay, so in the end, we had everything that Gary spoke about. We brought in data as is. We harmonized, we had the concepts, though I didn't call it what Gary Bloom talked about today, Data Hub, we used all the same concepts to get through this use case. And now you can imagine how many questions people are asking of it, right? Anybody can use this, and those graphs there are the lateness of shipments and excursions. Okay, so now anybody can search by any of the reference data. So you can search by shippers, carriers, by temperature, by date, you name it. You can just search like you had a Google experience. Okay, and now we are in production. By the way, now we're in production. I want to say that you saw that picture where I said the left side is always changes, in terms of data. We started with 3 data sources. Now we are in production, and we're already with 7 different data sources. Okay, so people saw the first round, and then they said, "Oh, I want to ask more questions. Let me add vendor bidding data. Let me add security data. Let me add all kinds of other stuff." Like we wanted the streaming sensor data coming from our temperature monitors on the shipments, and that's in our future. But I brought this slide back just to say that, this multi-model approach and the modular linked reference data approach has done well for us at Amgen. And I feel like all these use cases, I can do them all because we know that if you've got your concepts in order and you've got an environment to do this kind of work, you can do this. So I want to acknowledge my team, and I talk a lot about my SMEs, right, and the intergenerational diversity that we had in my team. We had youngsters and senior people who had worked in the organization many years who were doing all this manually, which was great, right? They did it manually, so they knew what they wanted changed, and they came, and we used to work a lot together with our team, Mark Furno, Greg McFall, Nish, and Michael. I mean, they're super brilliant. So being a biologist, sometimes I never knew how to articulate all that I wanted. I would say, I want to join this, I want to use semaphore, but they knew what to do with it. So they helped a lot to get this going. Let me, after the questions, I have an announcement. All right. I think I'm done with my presentation now.
Is this on? Yes. Thank you, Claire. Thanks for that. And now we'll take any questions. Just raise your hand if you have a question, and I will come to you with a microphone because we want everyone to be able to hear your question. So any questions in the room? I'll run, Claire. Here you go.
So it's good that you have already articulated how you have arranged your ontologies and all that stuff, right? But now, if you want to ask more questions, right, instead of, my whole point is, are you still relying on SQL as the end point for your users? Or are they able to, do you have any plans to convert or take this to the next step of ontology-based data access?
Yeah, that's a good question. So currently, right, none of my users know about SQL or Sparkle, okay? For this visual, you see that it's all flattened out into a table. But what MarkLogic's also done is we have a ontology expansion search, okay? So for product, right, when I said a product going from research to launch, you have several names that you need to query from, right? So using Semaphore's ontology, which has all those relationships, MarkLogic is able to do that semantic expansion search. So my users don't think of writing a Sparkle query or saying an and or search or any such thing. All they're going to know is they have that place, they go search, and they get what they want. But if there are people who want to delve into the data more from the back end, I am just picking up all the skills around Sparkle, and so we could create Sparkle endpoints for people if they had those kinds of questions. But the beauty of this model is that you're actually doing a lot more ad hoc questioning now because you've got your conceptual diagram correct, right? See, when you think of concepts, it's product, location, study, organization, right? It could be more, or genomics. So you have all these. And your questions are going to be across all of these. So if you've got that linked model in your head, or you've interviewed a lot of business users and say, tell me your questions. In regulatory, tell me your question. In research, tell me your question. In commercial, tell me your question. Your ontology model, that concept model that you're building, should address those questions. If you've done that, then ad hoc questioning is possible. That is why we've used the language. If you looked at these, if you look at these taxonomies, there's a human language that I've put here, right? You can see, it's very light, but you can see uses carrier, has transport type. That's the language my logistics people use. What's my carrier type? What lanes use which carrier type? So that's the language they use. So what we've done is all our ontology models have this language embedded. So in the future, you should be able to talk to a system and say, give me all the lanes where the carrier type is this. Ask the same question. So, but I want my users to have a no SQL writing, no Sparkle writing experience. That would be a non-frustrating experience, right? Where you can do that search on this dashboard, click on stuff, send it into Tableau, look at it, right? That's what I want to provide.
Anyone else? Oh, sorry. Apparently I can't see. Here you go.
Hi.
Hi.
From a semantic point of view, how did you account for different packages for each generic product?
So in the taxonomy itself, I built a model of all the, so shippers are packages, okay? See again, the language is so different, right? You wouldn't expect a shipper to be a package. So package itself is a huge taxonomy in Amgen, okay? It's package, the package type, the package dimensions, the temperature required on it. So all of that reference data is we've built out, and that's how we've managed the shipper semantics.
Okay. Anyone? Right back here.
Hi. Can you talk a little bit in terms of the deployment size, how much data you have in MarkLogic? Is it on-prem? Thank you.
So technical, but I'll try to answer it. So it's so these I've been coached on this, so I can answer it. Really, to be honest, it's MarkLogic is deployed on an Amgen AWS. Okay, it's a good question though. When we first scoped this, I went to my IT department and say, okay, tell me how much data do you have for these 3 data sources? Tell me how much data do you have? And so they said, it's 100 million records. Okay, I was happy, and we did the project, and now we are at 2 billion records. Okay, so everything's slowing down a bit, but we're beefing up the environment. So that was the size of data, really. Okay, 7 systems, around 12 years of data, 2 billion and going strong. No, not triples. We didn't. That's why this multi-model is so good, right? Because you don't have to triplify your whole world. That would not be good, right? You don't want to triplify your whole world. You want to maintain some things as they are, and you would get super pushback if you wanted to triplify the whole world.
So how do you balance where you distribute your information? Do you store some information in documents, others in triples?
Yes. And I'm going to ask some MarkLogic person to answer.
Just wondering, how do you distribute the information within your system? What are the information you store in as triples versus as documents? Just like you mentioned, there's a balance we need to strike, right?
So all my taxonomies are triples. All the taxonomies are triples. We've created a few triples in terms of saying this column of data is same as this column of data, because across different schemas, the field names are so different. So those are the places where we use triple. Okay. Yes. Such a complicated question. Oh my.
So just building on what was just said, are your triples therefore based on SCOSXL because you're using semaphore?
Please repeat, I didn't hear this.
Are your triples based on SCOSXL because you're using...
Yes, SCOSXL.
Okay, got it. So in which case your is related to connectors that you've got between the nodes that have details on them
Yes.
are just strings, or are you able to actually leverage that data which is sort of pinned to that is related to relationship?
You could use is related, but we use same as.
Okay, so you're doing equivalency.
Yeah.
Got it.
Anyone else?
These are all is related, but they're different relationships.
Okay, thank you, Claire. I would like everyone to remember to open their app and complete the survey for this session. Sessions that we create in the future or what we do next year all depends on your feedback. So please take a moment, it's really quick, and do that. And that's it. Thank you for joining us.